Radiation isn't just a problem for machines. It's a challenge for our very biology. Even on Earth, we're exposed to low levels of radiation every year, from the ground beneath us, from cosmic particles, and even from medical procedures. But our planet protects us well. Earth's magnetic field and dense atmosphere shield us from the worst effects. Mars has no such protection. Without a global magnetosphere, and with only a thin atmosphere, the red planet is constantly bathed in cosmic rays and solar radiation. For future Martian settlers, exposure to this radiation will be a daily reality. The question is, can the human body adapt to it? To understand this, we need to look at what radiation does to living cells. High-energy particles can damage DNA, increase cancer risks, weaken the immune system, and interfere with organ function. Unlike Earth, where these particles are filtered or deflected, on Mars, they can pass through the body unimpeded. Studies of astronauts on the International Space Station show us some of the effects. Over months in microgravity and higher radiation environments, astronauts experience changes in vision, muscle atrophy, bone density loss, and alterations in gene expression. Mars's gravity, about 38% of Earth's, will mitigate some issues, but radiation exposure may be greater than on the ISS. Over years of exposure, cumulative radiation could lead to serious long-term health problems. But there's hope. The human body, while fragile, is also incredibly adaptable. Our DNA contains repair mechanisms that correct radiation damage, up to a point. Our cells can recover if doses are low and spread out. And with proper protection and lifestyle management, risks can be reduced significantly. Living on Mars will require a combination of shielding, monitoring, and biological support. Martian habitats will be lined with radiation-absorbing materials, regolith, water, polymers, and even specially engineered plastics. Colonists will wear dosimeters to track their exposure over time, allowing mission control to manage rotation schedules and ensure safety. Even outdoor suits may be embedded with lightweight radiation-blocking fibers. And new drugs, called radioprotectants, are being researched that could protect cells from damage or speed up recovery. There's also exciting work being done in genetics. Scientists are exploring whether certain gene edits could enhance DNA repair mechanisms or make cells more resilient to radiation. In one controversial proposal, researchers considered borrowing genes from extremophile organisms, life forms that survive in high radiation environments on Earth, and introducing them into human cells. This raises profound ethical questions. Should we alter the human genome to adapt to alien environments? Where is the line between protection and enhancement? For now, these ideas remain theoretical, but in the long term, as we commit to multi-generational life on Mars, they may become part of the conversation. Another angle involves regenerative medicine. Stem cell therapies, organ regeneration, and bioengineering could one day repair radiation damage more effectively than we can today. Imagine stem cell capsules that repair internal damage during sleep cycles, or wearable biotech that monitors and stimulates cellular repair in real time. Mars will be the testing ground for such technologies. And success there could lead to revolutionary medical advancements back on Earth, helping cancer patients, radiation workers, and even astronauts heading beyond Mars to more distant worlds. But beyond technology, adaptation also means behavioral change. Colonists will need to limit time outside habitats, organize low-exposure shifts, and adopt health routines that maximize immunity and cellular health. Nutrition, rest, exercise. All must be optimized for resilience. Martian food may even be tailored to include antioxidant-rich plants and supplements that help mitigate oxidative stress caused by radiation. Infinity. Beyond believes the future of space colonization lies not just in rockets and robots, but in biology. How we adapt our bodies to new environments may determine how far we go. Will we remain Earth-bound creatures or evolve into something new? Martians, in the truest sense? This idea isn't science fiction anymore. It's biology at the edge of the possible. We may even see future generations of Martian-born children developing different physiological traits, stronger bones, altered immune responses, or greater radiation tolerance. Evolution, accelerated by environment and technology, could lead to a new branch of humanity. This doesn't mean we abandon Earth, it means we expand what it means to be human. In the end, the radiation challenge on Mars reminds us of a deeper truth. We are not invincible. We are fragile beings venturing into an unforgiving cosmos, but we are also resourceful. We build shelters against the storm. We design suits to protect our skin. We invent medicines to heal our cells. We change, adapt, and survive. Mars will test us in ways no world ever has. But in facing those tests, we may unlock new strengths within ourselves, physically, mentally, and genetically.